What's up, everybody, and welcome back to another video of Cephalo-Ed. In today's video, I am going to give you a little review about the cephalopod eyes. Compare them just a little bit, and give you guys just basic information. And so, before I get into this, I really want to thank Alexis, who has commented on one of my videos and actually suggested this video. I'm very grateful that you did that, and really excited that you did that, because I am not really experienced in the eye anatomy of the cephalopod. So it was really cool that you have mentioned that, because that gave me more information about these incredible eyes, and I learned quite a few stuff, and I have some of the information in it later in the video. So I hope you guys really enjoy it. I sure enjoyed this information. It's truly exquisite how advanced these cephalopods' eyes are. And then last thing I want to mention, we have a very, very, very special guest next week. They're an absolutely outstanding person. She is an award-winning She's an award-winning author, and she happens to be one of my best friends. She's a down-to-earth person. I love her so much. She's just an awesome person. And so I hope you guys like this video, subscribe to my channel, and oh my goodness, hit the bell button so you guys can get notification on when that video comes out, and get notifications on future videos as well. So last but not least, I hope you guys enjoyed this video, and let's get right into it. The cephalopod eyes. So cephalopods have a very special way of how the photoreceptors are shaped and packed in the retina, where this allows them to detect polarization of light. And this can be helpful for communication and coordination with their own species and find their prey. If you guys aren't sure what photoreceptors are, they are cells in the retina that respond to light. And retinas of cephalopods have a single pigment, meaning that they are monochromats. And unlike us, we have three pigments, and this helps us detect color. Unlike cephalopods, though, they have single pigment. And so the really big scientific word is right here, monochromats, is basically saying they're colorblind. And monochromats, this is caused from a cone defect or absence. And cephalopods have strange pupils. Cuttlefish have a strange W-shaped pupil. Octopus have an elongated pupil. Holy cow. Pupil. Narwhals have a pinhole shape, and squids have huge circular pupils. Mostly on the huge circular pupils, they'll mostly be on the largest squids, Humboldt squids, giant squid, colossal squid, and a few other larger ones that aren't as large as those guys. And mostly all cephalopods have transparent spherical lenses efficiently that focuses on larger amount of light in the retina. And coastal and benthic cephalopods have a corneal membrane that covers the lens for protection. So this corneal membrane can help protect from the saltiness of the ocean, because it's very salty, and probably also from the, I can't get my word up, but I'll just say the acid from the acidity from the ocean, and also particles and other stuff that seem to float around in the ocean. And before I get off of this slide and go to my next one, I want to talk to you guys and give a little fun fact about the cuttlefish and octopus pupils. So it is believed that cuttlefish and octopus pupils shape allows them to detect color based on distortion of the image from the edge of the pupil. So this is just truly outstanding how their pupils are engineered to actually catch some of the light at the edge of their pupil, it's really interesting they are able to do that. And also another cool little fun fact. So we Homo sapiens, we have 120 million photoreceptors. So mollusks have a very small amount of photoreceptors. They have 4 million photoreceptors. I know it sounds like a lot, but compared to the others and us, it's very small. Octopuses have 20 million, and squids have 1 billion photoreceptors. And you can tell the squid just takes a prize for the amount of photoreceptors. The squids take a lot of light, and this helps them to really have that acute eyesight that they have for spotting out their prey and spotting out their predators to get away, and also kind of see where they're going. And let's get into a basic little anatomy of the cephalopod's eyes. So I did a lot of research trying to find all the cephalopod's eyes anatomy. It was really difficult, but this makes a lot of sense that octopus, squid, and cuttlefish eyes all basically are the same. It makes a lot of sense because when you just really look at them, they all look alike, and once you get deep into the eye, it just kind of all gets them together and just kind of makes a lot of sense. So we'll start from here. This is their cornea. And then right here, that's their pupil. And then you get to this blue part, which is their lens, which is that really cool, glassy, kind of squishy part that is in their eye. And then you get the ciliary muscles, which help to contract the movement of the pupil. And I'll talk about something really fascinating about this after. Then you got the iris. Then you got this huge part right here. This is just this liquid mass that is in the eye. And all around here is the retina. And then back here you get the optic ganglion and the optic nerve. So what's really just so incredible about cephalopod's eyes is they have the ability to do this camera focus. So when you guys are taking pictures of something, you guys want to zoom. Say if you want to zoom in a picture, or say if you have one of those really nice, expensive cameras where you have to move it in, it'll zoom in at this perfect distance you want. This is actually how cephalopods are able to really get a good look at something that's far away. They're able to zoom in. Unlike us, we can see, but we can't zoom on stuff. You can see stuff far away, but with these guys, they can zoom in really good and get that perfect image that they want and what they're specifically looking for. And then the retina is one of probably the most fascinating parts, because their retina, it just goes all around the eye. And unlike us humans, our retina goes through this mass and then to here. So if you guys want to get a good visualization, pretend that all this right here is your security camera out front, out front of your house or in the back of your house, wherever. And it's hardwired, so you get those wires. So instead of drilling a hole through the wall and then put all the wires through there to go onto a monitor or something that you would put the wires onto to put on a computer or anything, their wires just go all the way around and right back here to where the brain is and all that special stuff, the optic lobe. And so these guys don't have to drill that hole through the wall to get their retina to go in here. So this gives them their extraordinary ability to not have a blind spot. We have a blind spot because our retina is going through, and that goes in our blind spots right in the middle of our eyes. And so we'll get those blind spots, but unlike cephalopods, they have incredible vision, no blind spots at all. And what's also extremely incredible with the octopus, cuttlefish, and squid, they have a full 360-degree view. Meaning by that, when you guys observe chameleons, you can see one eye individually moves somewhere. It'll move to the left, and then you can get the right eye that can move to the right or move up front, just eyes individually working. And this is exactly what they are able to do. So a cool little word that you'll hear a lot sometimes is they're the advanced chameleons of the sea. And that's basically what they are. They got that special movement for the eyes to get that full view of what they want. They don't have that blind spot. They can zoom. And then they have the more advanced way of changing into their surroundings, which is just so amazing and it's just awesome. And so that is basically what I really wanted to talk about, you guys, for the eye. It's just truly magnificent how incredible their eyes are engineered. It's just so suited for them. It's perfect for the needs of survival. It's just so incredible and amazing. And so now I just want to give you guys just a few pictures of the eyes of cephalopods so you guys can see what I mean by the W-shaped and elongated shade, the pinhole, and the giant circular pupil. So right here we got our octopus eye. We have that elongated shape. It can also kind of, their pupil can close a little bit, almost like our eyes, how our pupils can get large and then go back to small. Their eyes kind of do that, but they don't do it like our eyes. Their pupils are a bit different. But what's also really fascinating, as you guys can observe here, there are chromatophores in their eyes. I'm not sure if it's embedded in that special membrane for protection or it's actually in the cornea or eyelid space, but it's truly outstanding how their chromatophores are embedded in there. It does kind of make sense why they're there too, because if the octopus or squid, cuttlefish want to transform or camouflage into, say, seaweed on a rock, their eyes will be able to change into that too. But if their chromatophores weren't there, their eyes would definitely be not as invisible, so it'd be more easy to find that octopus, because that whole area here is just all white and just kind of just wreck up their camouflage a little bit. And then cuttlefish, they kind of have the same exact thing. Their chromatophores are embedded in here, and I put a circle around here just in case if any of you guys were confused on where the eye was. And so they got that strange W shape, which is just really fascinating how their eyelids like that. It's really cool. And then the eye of a squid, you cannot miss this. It's really easy to tell if it's an octopus, squid, or cuttlefish, because you get that elongated one, that W shape, and just a squid just had this huge circular pupil. And these eyes are just so advanced and perfect for visualizing their environment, predators, prey, etc. It's awesome. Then you get the nautilus. It literally looks like someone took a pin and just shoved the pin in the eye, took it out, and just said, yeah, here's our eye for our nautilus. It's really weird how their eyes like that. It's really extraordinary. It's so fascinating how it's like that. So that is it for today's video, guys. I hope you guys enjoyed this. I did. I loved finding new information to give to you guys. It definitely educated me a little bit on the eyes, and will hopefully definitely educate a little bit on you guys' eyes as well. Also, if you guys want a more advanced video on the eyes, please just put something in the comments by all means. I would love to give you guys a more advanced videos on the eyes. Would be really cool and probably learn a lot of new stuff about it. So just please do whatever you want. And like what I said at the beginning of the video, just please like, subscribe, hit that bell, get more notifications on videos in the future that I will be making, and especially for our very special guest for next week. So that is it for today's video, guys. I hope you guys enjoy and have a fantastic day.